So, when you returned to India, you ran a seminar on Grothendieck schemes, but the language of schemes and sort of the scheme theoretic approach to algebraic geometry did not really take root in TAFR till later. Do you agree?
Yes. See, the geometric problems, for example, in Picard varieties, or in even in the later the works one, the classical algebraic geometry was enough.
Okay.
See, but the construction was what is called code schemes, etc. That was not done by Grothendieck. It was announced by that. Then I again began a long course in algebraic geometry, from scratch, where schemes were introduced. I just want to have a complete proof, all the further the work and.
You were still looking at line bundles and not vector bundles at this point. Your motivation to get into schemes, that's because see your work with Narasimhan. I mean, so we will come to this. I want to understand when you began looking at vector bundles, and then geometric invariant theory from the point of view of modular vector bundles. But I want to backtrack a little, just to get the chronology straight. So you kind of, I think that from what you said, the two big influences on you were, well, three. Start with Ambrose and then Laurent Schwartz's lectures. But then what seems to have really taken your imagination was Zariski's lectures, right? I mean, that is when, from what you were saying earlier. So, and Zariski's lectures happened after Laurent Schwartz introduced complex manifolds and so on.
Yeah.
But you continued to work in the complex analytic spirit after hearing Zariski.
Yeah.
So the more algebraic approach to geometry you returned to later. I mean, after you went to Paris, right? Because from the chronology, it appears as if you were still looking at open Riemann surfaces and so on after Zariski. No, or am I wrong?
No, let me say, as I told you, the initial years, Narasimhan and I probably he was interested in more differential kind of geometry, later probably. But you see, we did not know in which subject we are going to work.
Okay.
There was also lectures on convex, what is this, convex spaces, that is the generalization of Hilbert spaces.
Okay.
There was seminar in that.
Okay.
There was seminar on topology, fundamental. So many things, but nothing was.
But this Zariski's lectures made a big impression on you. That seems to have, I mean, sort of been in weight in your mind, so that when later on your approach to algebraic geometry was more algebraic than say Narasimhan's, right? I mean,
But my complex analytic background also
helped.
If I'm not mistaken, the transition to vector bundles was influenced by Wales' paper very much, right?
Yeah.
Which also you spoke about. Is that you had read?
I will say about
that. You said that was the first paper you read very carefully. You said
the first paper, which I read thoroughly, which was let me say, which was useful for me for several things to get my thesis to work with Narasimhan.
I think even though I would be hard pressed to say, and in fact at some point we should ask what exactly is in Wales' paper, because it's a paper with a philosophical viewpoint without. Is there a theorem there?
Yeah,
there is a theorem. Yeah. Okay. Okay. So now tell us about your collaboration with Narasimhan.
See, Narasimhan and I, this paper which we wrote, that a very stable bundle is associated to unity representation of the fundamental group. There were several backgrounds. That is how Hermann Weyl states that any line bundle of degree 0 is given by a representation of the fundamental group or a homology group. Then this was this stayed in this one. And then of course my experience with line bundles. On the other hand, Narasimhan had differential geometric approach, this one. And sometime in 62, then this theorem that the unitary representation, irreducible unitary representation is a complex structure. That was the first theorem of Narasimhan and myself. And then we had, there was so-called simple bundles, automorphism. Then there was a question whether they are the same. Then Narasimhan and I were working on that. Then I wrote to Mumford. No, it is the simple bundles, or that is not the stable bundles. And he sent a copy of his notes, and also I think a copy of his the geometric invariant, the previous one. He had written a paper. That one we studied it well, and this was I would say shortly the influence of my early influence from our joint seminar on Riemann surfaces, and this one, and André Wild's paper, and Mumford's work, and Narasimhan's. We were able to putting together all these things. We were.
How old were the two of you at that time?
I was 32.
Had you met Mumford before that, or
no?
Only mathematical correspondence.
Mathematical correspondence. I had heard of Mumford.
Narasimhan has told me more than once, quoting you, that I think he used the word grace for what happened to the two of you. Your discovery is he actually quotes you. I mean, I don't know if you recall that you say it's a moment of grace.
I would say,
yeah. Okay. So now to geometric invariant theory, it seems to me that it has been a major theme of your work, starting when you realize that it was so tied up with stable bundles, and then it also maybe tell me. So you have been trying to construct moduli spaces before geometric invariant theory was sort of invented for this purpose by Mumford, and so when you saw the invention of geometric invariant theory by Mumford in this context, did you realize that this is the thing, right? And then you spent 10 years working on very foundational aspects of geometric invariant theory as well.
You see, after the work of Narasimhan, that the stable bundle is irreducible unitary representation, by that paper, then construct this variety, which then that was the problem. That is, construction of the stable bundles is not a projective variety. It has to what out its some nice compactification. Then the nice topological compactification is the set of all irreducible representations.
Right.
All right. Then on the set of irreducible representations, which is not even a good algebraic space, then there exists a complex structure and this can be constructed by purely algebraic methods, and therefore this construction I did, and that was based on Mumford's work. Also, my experience with quotient spaces, I had a even before I met Mumford, I was if you have a nice action on a variety, nicely defined variety, quasi-projective or something, then a group operates freely, then the quotient need not exist in the category of algebraic varieties, but up to a finite covering. This was the theorem which I was, and before I used to read very often the Shimura's paper on abelian varieties in the Karthav seminar, and from that it was obvious then these varieties could be constructed algebraically in the sense not as quasi-projective varieties. I didn't write it in my paper at all. That was the kind of things I could. Then when Mumford said the abelian varieties, you take points of finite order, and then it is you take an embedding, projective embedding, and then the quotient problem reduces to, it is embedded in a product of projective spaces modulo the algebra. And I thought it was a great step, because I was so impressed by that, that the first algebraization problem. And also he also announced that on stable bundles also there is a projective variety. I had not meant Mumford. Then I read this International Colloquium paper in 62 or something, Mumford's one, and I could then reconstruct, and also what he has done in geometric invariant theory, I could reconstruct that one. And when I was trying to understand this, I could also prove that the construction of the moduli space of vector bundles, stable vector or semi-stable vector bundles under some. This was how. Then the next problem was, this was all in characteristic 0.
Right.
Whether this
so in the process you discovered S equivalence. In the process you discovered S equivalence. S equivalence.
Yes.
Okay.
Yes. Yes.
I mean.
Yeah.
Please go ahead. Yeah.
But now what happens in characteristic P? You see, then to prove something is proper in the first construction is I use Narasimhan, paper with Narasimhan, that this S equivalence of semi-stable bundles as set theory, this is simply quotient of the unitary representations by the and using Narasimhan's theorem, which is a compact, this theorem, this S equivalence is a set of all representations of
yes,
and this is a compact space. But now how do you prove directly that one? Then I was thinking of that. I went to Harvard, I met Mumford, and I wanted to solve this problem, first characteristic P. Then all the modulo what was called Mumford's conjecture, if it holds, then it holds even in all characteristics. I was trying to construction by the invariant is finitely generated. Then Mumford told me, no, that's not the Mumford the conjecture, everything follows. Then I thought for a long while, I mean 1 month or something, without about that I could do it for 2 variables. And then the Mumford's conjecture for GL2 was proved.
You proved it?
Yeah, I proved. And with that the algebraic construction in characteristic P for rank 2 vector bundles also. But if you proved a conjecture for general, then you know the history of the problem is then I came back. Raghunathan got interested in that one, and I had a nice proof, which is and later the Habusha's proof is just it's a kind of generalization of very beautiful generalization of this work, and that relies on Steinberg irreducibility. Unfortunately, Raghunathan also did not know that, otherwise he would have solved it at that time. And afterwards also in practice, you see, when you want to apply geometric invariant theory, this you also want to have a base, which
Yeah.
is.
Yeah.
Then I wrote that paper, Geometric Invariant Theory over a base.
Yeah.
That's the.
And then just staying within geometric theory, invariant theory, and vector bundles, you also discovered parabolic bundles. I mean, I use the word discovered because you have to. It's a discovery. I think.
Yeah, there were two problems
yeah.
after our first paper with my first paper with Narasimhan. Construct these moduli spaces in all characteristics, or even over a base of one. Therefore, that is one problem, and then, but Andre Weil's vector bundles, the Andre Weil's thing is not exactly a vector bundle, but he used to take some finite isotropies and therefore my was to understand this. Then I found out that the Andre Weil's what the definition of his vector bundles are really vector bundles with parabolic structures.
Right. Right.
And then the construction I did
Right.
also,
And I think this is also the first example of in sort of real life where different polarizations, are important. I mean, are important.
I also do that variation of polarizations,
Right.
etc.
Right.
And I had also said that I had the good fortune, I lectured on that. I didn't even publish that paper. Paper was published later. Even when I went to Princeton, Andre Weil also was there, and it was quite satisfactory, he said.
So the fact that if you take a representation of the fundamental group of a punctured Riemann surface, then you attach to that an object on the completed curve, that must have come as a very satisfying insight for you. Yeah. Maybe you want to now.
Well, tell us more. The 64 colloquium, I think Narasimhan spoke on your joint work.
No.
1964.
No. 1964, Narasimhan talked about the first paper. Myself and
your joint work. That's what I said.
Not the.
No, for the case of degree 0 vector bundles.
No.
The stable. The complex structure on.
Complex structure on irreducible unitary representation.
Oh, that's what he spoke on. Not.
That was our first paper.
I see.
And the problem was solved soon afterwards. We solved that problem.
By 64, you had done that work about stable bundles being unitary bundles. That was done by 64.
64, I remember even very well that the first draft was being written. But the colloquium was not
64 colloquium is the differential analysis.
Not at the end of 64. It is beginning of 64.
Okay.
And then actually from that I realized that this one, for rank 2, you can give a proof for the construct this Narasimhan paper that rank 2 can be fairly easy, this one. And from that, it is somewhat technical. The stable bundles are open, or this was, or semi-stable bundles are open in a sort of family of vector bundles. This was which I knew that in Mumford's announcement, it seemed like that. It was announcement. Before the Narasimhan and this paper, Mumford does not do stable bundles, only does stable bundles. Semi-stable bundles, he doesn't do that at all. And then the difficulty was to have also a theorem for where the degree is not 0. In the inductive procedure, degree was 0, and that was done by some, and that didn't use geometric invariant theory. See, that is the. Therefore, it was this, and of course now Raghunathan has a very simple, much more direct of proving stable.
You know, after you came back from Paris, you joined the faculty, right? Tell us about your career progression in the Tata Institute. You were appointed reader when you, as soon as you came back from.
No.
No?
We were still
As soon
fellows.
as you came back from France.
Soon afterwards, we were made reader.
After you came back from France.
Yeah.
Okay. Then you were reader. Then when were you made a faculty member? Those days, went associate professor. When was that?
Associate paper, I think in 62, I forget. But
in the 68 colloquium, you spoke on the Mumford conjecture.
Yeah.
You must have been on the organizing committee for that
Yes,
colloquium.
yeah.
And I mean, by that time, Chandrasekharan had left, right?
Yeah.
So, who was the
The dean was, chairman was K
Ramanathan? K Ramanathan. He was the.
But the selection committee, as you know, that almost practically, it was a wonderful event because all the great algebraic geometers were there. I mean, except Zariski didn't come. Grothendieck came. And
by the way, did you know Grothendieck when you were in France?
Oh yes, yeah. So actually, when the first SGA talk was given by me.
Huh?
Given
by?
Me.
You gave the talk, I see.
Of course, I was at sea. And when the institute also, it was in a different place, near Etoile. Actually, the conversation, the Grothendieck, after I did the Picard variety, said that, of course, you should now do with nilpotent elements, this Picard variety at this point. And I didn't do, actually Ort did that later.
So the choice of speakers and so on must have been largely yours.
Actually, no. Grothendieck took over.
You mean for the colloquium?
Oh, because don't know who are the speakers. He said, Griffiths, you should invite him.
So Grothendieck was member of the organizing committee.
I mean, yeah, and therefore practically he took over.
So the practice in those days was, I mean, even now I suppose that there are always two nominees of the IMU on the organizing committee of the colloquium, right? Grothendieck was one, who was the other?
I don't know. I don't know. Maybe I was, I don't know. But practically it was taken over by of course, there were people like, Mumford, Griffiths. Hironaka didn't come. It was a singular exception. He was also in Harvard. I knew also Hironaka very well, even before it, quite a few years before he proved his desingularization. He came to Paris, and Matsusaka was there, Abhyankar was there, Igusa was there. For the colloquium.
1968.
Andre Weil was there.
Weil was there, of course.
Weil was there.
Famous story, no?
Yeah. Andre Weil, Grothendieck, and I don't know, others I have forgotten.
See, there were 3 Japanese whom Abhyankar whisked away in the midst of the colloquium to Pune. So Igusa is one, Matsusaka is another. I don't know who the third, I don't remember who the third is.
On Sunday. I think, I don't know, I gave a talk on Sunday, I think, in the colloquium, if I remember well. Yeah.
So it is essentially Grothendieck who decided on the speakers, that's what you say, huh?
Some speakers were decided before, but he took over, sort of.
You were the only one from the institute who spoke in that colloquium?
Narasimhan gave a talk. Oh, no.
Not in the 1968?
Yeah. 1968, they gave a talk. They gave Ramadan and Narasimhan paper.
So 2 talks from the institute.